A vast amount of data is now available to answer several key issues about our galaxy. The data obtained by the Gaia mission of the European Space Agency offers an extraordinary quantity of information on almost 1 billion of the brightest objects in the sky. Astronomers expect that the new data, which will be revealed on June 13, will help them solve some of the biggest mysteries surrounding the Milky Way's birth and life, as well as the stars that make it up. So, what are some of the mysteries that Milky Way researchers are aiming to uncover? What is the sole purpose of the Gaia mission? Stay tuned as in today's video, we take a look at 4 big Milky Way mysteries the Gaia mission data will solve. The Gaia mission. The Gaia project, which was launched in 2013, is credited with creating the most detailed picture of the Milky Way, showing the precise coordinates, distances, and velocities of approximately 2 billion stars. The next data collection will add a new dimension by revealing the chemical composition of tens of millions of stars, allowing astronomers to answer key issues. Gaia examines the entire sky every 2 months. The 2 billion celestial objects seen by the telescope account for less than 1% of the Milky Way's total number of stars. Astronomers may extrapolate these readings to learn about the galaxy as a whole using sophisticated computer algorithms and a plethora of scientific information. So, what are some of the most intriguing mysteries that Milky Way scientists hope to solve with the new data? Number 1. Where do stars come from? Gaia accomplishes much more than chart the Milky Way as it is today by measuring the precise locations, distances, and velocities of massive numbers of stars. The Gaia mission team will reveal astrophysical parameters for 500 million stars for the first time. The chemical composition, mass, age, temperature, and brightness of each of the measured stars are revealed by these characteristics, which are determined from the light spectra of the stars observed by Gaia, which are effectively the fingerprints of how these stars absorb light. Gaia detected the chemical composition of stellar atmospheres for 30 million of these stars, which is identical to the chemical composition of the molecular clouds in which these stars were created billions of years ago. Astronomers will be able to track groups of stars to their birthplaces, both inside and outside the Milky Way by integrating chemical composition data with stellar trajectory calculations. Number 2. How does the galaxy hang together? Despite the fact that Gaia has been scanning the Milky Way since 2014, there are still many things scientists don't know about the galaxy. It's not easy to research our galaxy's home. We can't see the forest for the trees since we're within the galaxy. However, the big picture is gradually coming together, piece by piece, thanks to improvements in Gaia data and other observation techniques like radio astronomy. That means we're coming closer to answering some of the galaxy's biggest mysteries, such as the distribution of dark matter. According to Gaia project scientist Bruini, everything in the galaxy exerts gravity on each star, and this gravity influences how rapidly the star moves. As a result, when you measure the motions of stars, you're probing the Milky Way's matter distribution. And this is critical for understanding how the galaxy hangs together. Number 3. What happened in the childhood of the Milky Way? During Brown's terrible upbringing, the Gaia-Enceladus collision was the last significant merger the Milky Way undertook. Astronomers will now be able to dig deeper into the galaxy's past and trace some of the even earlier collisions using the new data set. They can figure out the temporal order of events now that they know the age and chemical composition of the stars. And they can also understand where the stars originated from now that they know their age and chemical composition. To this day, the Milky Way continues to swallow smaller galaxies. According to models, the Milky Way will one day totally absorb 2 dwarf galaxies, known as the Large Magellanic Cloud and Small Magellanic Cloud, which orbit the Milky Way's outskirts. Other dwarf galaxies' remnants can be seen as star streams strewn over the Milky Way's halo in the Gaia data. Number 4. What is wrong with the disk of the Milky Way? According to previous Gaia findings, the Milky Way's disk is curved rather than flat. It also wobbles like a top as it spins around the galaxy center. Astronomers assume that the wobble was caused by a recent galactic collision. Brown is hopeful that the new information will give further light on the cause and origins of the disruption. The forthcoming data release will include information on the motion of nearly 30 million stars in Gaia's field of view, including their radial velocity. However, only 7 million stars' radial velocities were included in previous versions. The more data astronomers have, the less knowledge about the galaxy their analytical methods can reveal. They can try to quantify the disturbance in various locations throughout the galaxy or examine how it affects different sorts of stars. And this tells us a lot about what caused the Milky Way's disk to be perturbed in the first place. Well, the mission will continue to survey the skies until it runs out of fuel in 2025. Following the June 13 release, 2 more huge data releases are scheduled, each bringing unexpected surprises, including thousands of newly found exoplanets. So, what are your thoughts about the Gaia mission? Is it worth it? Are the mysteries being unfolded? Let us know in the comment section below. And go through the channel for more videos like this. Thank you so much for watching. Until next time.